Welcome to today's class. It is my greatest pleasure to know that you're actually watching this video. This video will provide solution to the assignment that was sent to you. It was actually sent to you to show you the other side of calculus, so you don't think that it is always the normal way of doing things. Now, look at this question. You have integral of 5 tan x over tan x minus 2 with respect to x being equal to this, and you have to calculate the value of a. What we are going to do here is this. Please, there is a general concept in calculus that whenever you are giving integration and you are now giving the other side, that is, you are giving the answer to this integration, and there is a constant there, or any value or known value that you have to find, the best way of approaching is towards differentiate. So here I'm going to differentiate both sides. So let's see how this works. The first thing is solution. So we have differentiating both sides. And if you are doing that, let's see how that will work for this. If I differentiate integral of this, of course, it will just cancel integration and I will have my values back. Tan x minus 2 equal to, if I differentiate x, the answer is 1, plus, now I have a ln sin x minus 2 cos x. Please, this is where the problem will be for majority of us that will be attempting this. Whenever you have integration and the answer is a ln of any value, it simply means that the numerator of that expression is the derivative of the denominator. I take that again. It simply means the numerator of this expression is the derivative of the denominator. And for the fact that you are writing this, that means the denominator is sin x minus 2 cos x. That's what it means. And from there, we will now use this to find the numerator, and that is, take for instance, I have sin x. If you differentiate sin x, what will it be? It will give you cos x. And I have minus here. If I differentiate 2 cos x, the answer will give me what? Minus 2 sin x. And if you multiply minus by minus, you will have plus 2 sin x. That's that. And of course, if you differentiate constants, the answer is 0. So from there, we'll move on. And that means here I'm going to have 5 tan x over tan x minus 2 equal to 1 plus, here it will be good for me to just find the LCM straight. Let's find the LCM, and if you find the LCM here, the LCM is going to be sin x minus 2 cos x. So here, since this is 1, I have 1 over 1 here, of course. 1 in this is sin x minus 2 cos x. I multiply by 1. Of course, I will have sin x minus 2 cos x. And if I have sin x minus 2 cos x, which happens to be the same as my LCM, of course, that the 2 will cancel out, giving you 1. Multiply what you have in the numerator by 1. Of course, you get this, which is a cos x plus 2 sin x. Yes, so, and if you check, there's no way I can compare both sides there. So, and I think that would be the easiest way of doing that. So let me think of something. I want to remove everything that has to do with sine, since I have sine and cos here. So if I want to do that, of course, sine is the same thing as what? Sin x over what? Cos x. So here I'm going to have 5 sin x, 5 sin x over what? Cos x, divided by what? Sin x over what? Cos x, minus what? 2. And that will be equal to, let me just do something here. Let me open the bracket there. If I open the bracket, I'm going to have sin x plus 2a sin x. Of course, then here will be a cos x minus 2 cos x, and everything here will be divided by sin x minus 2 cos x. So let's take it a bit up, and if you do that, what will this be? Let me get rid of cos x since it's occurring on the denominator from both sides. So here I'm going to say multiply both sides by cos x, and if you do that, let's see, just multiply the left hand side by cos x together with the numerator. This is what you will get. You have 5 sin x over what? Cos x times, let me change this to cos to red so that you can see it clearly. Then I'm dividing sin x over cos x minus 2, then multiply by cos x. So what this will do for me is that this will cancel this, and of course if I use this to multiply this, it will cancel out, and 2 times cos x will give me 2 cos x. Don't forget, if I'm using cos x to multiply the bracket, I must use it to multiply each number or each variable or value inside the brackets. So cos x here will cancel out. 2 times cos x will give you 2 cos x, and of course this will be equal to can I collect like terms? Of course I can. So that will be here will be 1 plus 2a sin x, 1 plus 2a sin x, because if you check very well, sin x is common, plus, let's see, this will be a minus 2, then cos x. Cos x is also common here, and that will be divided by sin x minus 2 cos x. So quick one. So if you do that very well, your value here will be 5 sin x, all divided by sin x minus 2 cos x. Don't forget multiplying it. Then here you have 1 plus 2a sin x plus a minus 2 cos x, all divided by sin x minus 2 cos x. So if you check very well, you will see that these two, they are the same. I can easily cancel them, and if I do that, I'm going to have something here which is 5 sin x equal to 1 plus 2a sin x plus a minus 2 cos x. And if you check here very well, I can just go on and compare coefficients of sin x. So let's put it there, comparing the coefficient of sin x. So what will that be? If you do that, you are going to have 5 here. This is the coefficient of s. 5 equal to what? 1 plus 2a is also the coefficient of sin x. So can I just make a 2a the subject of formula? That will be what? 5 minus 1, which implies that you have this. So therefore a will be equal to 2, being the value of a. So I want to believe you understand this. Make sure you go through, and I tell you, you will definitely understand it.